Okay, today we have Ian Durbach. He's a researcher at SEEC, although we're sharing him with CREAM now, with the Center for Research into Ecological and Environmental Modeling at the University of St. Andrews, where he's working on a couple of very interesting projects, designing the camera trap surveys of snow leopards, trying to estimate the total population, and also doing some research on behavioral responses of whales to sonar. And then he's also looks at how to apply machine learning techniques to ecological problems. And I don't know if you're still at Ames. No, not anymore. So I'm going to leave you with him. We're running a bit late. Sorry about that. Thanks, Ian.
Thanks, Bachi. So sorry for the technical problems, but I'll try to go through as quickly as possible and still finish in time. So this is not a statistics talk at all. It's just basically about how you can use R and RStudio in the cloud, or a little bit more, just getting a little bit more out of RStudio. So I'm not going to make this full screen just because there's only 2 or 3 slides on here, and then we'll do a hands-on tutorial. So that sometimes is a little bit kind of dangerous doing a live demonstration, but I hope everything will work out okay. So what I'm basically going to talk about is how to access R other than using it just on your laptop locally. So accessing R remotely. So the first thing is, why might you want to do that? And the kind of most obvious or immediate answer is that you want to do an analysis that you don't have the computational resources to do on your laptop. So maybe analyzing a very big data set, or something that's very computationally intensive. Those are the sort of main arguments for using cloud computing or using a remote server. In fact, what I have found it more useful for is just basically, often you want to free up your laptop just for like everyday work. You have something that's going to take like a couple of hours to run, and you just don't want to not be able to use R for a couple of hours. So that's like the reason why I use the resources that I'll talk about most often, rather than doing big analyses that I actually can't do on my laptop. So any of those things are valid reasons for why you might want to use some of the things that we'll talk about. Why not? Or what are the downsides to using cloud computing? Well, you need to be online for one. It can cost money, and the last option we'll talk about, Amazon Web Services, the pricing can get expensive if you're using some of the more computationally intensive servers that they have. Plus, you need to factor in if you're doing everything locally, all your data's on your computer and it's easy and you know everything is and stuff. If you're working remotely, you're going to have to upload your data, download your results, and that can also take time. So you have to do a kind of a cost-benefit trade-off to know, or to figure out if it's going to be worth your time to do something remotely. Okay, so I'm a statistician, so I don't know very much about the details of cloud computing, and so if there are any sort of computer science people here, the following phrases may contain some really dodgy terminology. But I think of it in there are basically three options for working remotely. The one is that you've got a computer sitting somewhere, like a SEEC server, and you access that remotely, through a VPN or something like that. Something some software like TeamViewer allows you to do this. So there's just a computer sitting somewhere else, and you access that through the internet. So that's like a single server, and that can be useful just for getting stuff off, freeing up time on your laptop, but you're obviously constrained to that single server, so whatever's on that computer, you're constrained to use that. The second option is a cluster, and so there's a UCT, high performance computing cluster, or the CHPC, and that's just a bunch of computers that are connected together in a network, like in a physical network. And those are great to use, and you can scale up and down the resources that you use, but often they're not that user-friendly. So you need to You need to log in and install packages at the command line, and it's just generally sometimes quite a hassle. There's quite a higher barrier to entry. Cloud computing is the same idea. You've got kind of infinite computational resources, but just not connected physically. So you can again choose how many resources you want, and you can install packages and stuff like that. Some of these are also difficult, like there's a barrier to entry, and you have to do stuff at the command line. There are some easier options, and those are the ones that I'm going to focus on. Basically, it's stuff that doesn't need you to work at the command line. Okay, so I'm going to show you three things. The one is not a remote option at all, but it's something that's new in RStudio, and it allows you to basically continue working and coding while running a job. So although it doesn't fit into the cloud computing kind of option, I thought it's a nice thing to start off with. If your main aim, like me, is often just to free up, be able to work in R while you're running something that takes a few hours to run. So it's called, the feature is called RStudio Jobs. And you'll see in the newer versions of RStudio 1.2 and up, you get this little tab here that says Jobs. All it really is that you can run a script file in the background. It will start a new instance of R. In the background, you won't see it. It will run your code in that instance, and it will close the instance down once your code has run. So say I've just got some example code here that just does some stuff that takes a while. So if I run this, if I just say source and run, it's like I can't do anything in RStudio until it's finished running. So what you could do is open up like a separate R and kind of, but then you quickly run. You can only do that with really one other instance of R. So under jobs, I can say start local job. I'll run the script file. I want to copy the job results. So if you don't do this, basically just runs the script and that's it. It doesn't save your results anywhere. So you want to say copy the results to the global environment, and I'll start that running. So while I'm doing that, this thing is running. There's a progress bar. You can use things like these are code breaks that will say, like when it gets to this bit of the code, this line will change from making Y to making Y2. So it just kind of, you have a little bit of control of knowing like how far your job has gone. And I can keep on working and doing stuff like in RStudio in any of the other script files, just as if I was working. So this is just kind of running in the background. If I want to submit this as another job, I can just start another job. That will again run in the background, and I can do my normal work and just carry on doing it as is. So this is a nice feature if you're just trying to basically, if your reason for using a remote server is to free up time on your laptop for everyday work. There's obviously going to be some kind of resource constraints. So if you do dozens of these, it might be, yeah. I'm not sure, actually. Yeah. So the question, I don't know, do I repeat questions for people that are listening? Should we just leave that? Question is, does it use less CPU or does it just use everything it can? I'm not sure. I think that there is some kind of there is some scheduling. It does try and do it in a clever way, but I'm not sure how clever that is.
You could show up the different cores, on the activity monitor.
Yeah.
On the activity monitor, you can just see how your multiple cores are working, see if it's on the
Yeah. Okay, so that's option one. That's not cloud at all. The second option, yeah. I need to resize this window quickly. Apologies. So this is a new, in the abstract for the talk, I was going to talk mainly about Amazon Web Services, but which I will get to in a couple of minutes. But in the last couple of months, I've become aware of this RStudio Cloud, which is a new cloud service that RStudio is offering, and it's free and it's really easy to use. So I thought that this is a better place to start than with Amazon Web Services. I'm not sure exactly what the downsides are, except that you won't have as much flexibility in terms of choosing your underlying operating system or the amount of computational resources that you want to use with the free version of that RStudio offers as you do with Amazon Web Services. But aside from that, I'm not sure. So you need a Shiny Apps account. That's free. After you do that, you can just go to RStudio Cloud, log in, and follow a few easy steps, and that will get you up and running on a cloud instance of RStudio. So it's based around the idea of projects. So I'm not sure how many people have used R projects, but it's just basically a way of organizing your script files and everything into one folder, so it avoids having to set a working directory and things like that. So we'll start a new project. That will start an instance of RStudio that is on the cloud. So using RStudio's cloud computing services, you can upload data, do your analyses, and it will just work as if you were working on your own computer. This will take a minute or two to get up and running, but just say there's this useful guide which takes you through all of the details. Oh. I literally never seen this. A timeout.
Yeah, the one you saw before was 2607C21.
Let's just close that and hope it goes away. Okay, so anyway, let's see. There's a guy that will take you through the steps involved, but it's really as simple as that. And you can have multiple projects open. What should pop up here after a while is a window that looks exactly the same as what you get when you open RStudio. You can share, so you can keep it private, or you can create, or you can get a link which will allow you to share your project with other people that you're working with.
Can you clone a project from GitHub or something?
Yeah. Okay, all right. So this looks like you're working on your own computer, but you're working on the cloud. And so you can start analyses, like, come back a day later and pick them up. The sharing, like I said, there's this access, and this says who can view this project. Everyone. If you click everyone, then you'll get some instructions, links to share with other people. So that's a really quick, easy way for running your analyses on the cloud. You see that you don't have any control over the size of the computer that you're working on. So I'm not sure. There are some priced options, but I haven't explored those at all. So I guess if you're running into issues that things are running very slowly, or like you want to use a data set that's too big for this free version, you may have to pay something. But I think the idea is to get people up and running on this free version, and it's probably quite well provisioned. Okay, so those are two quick and easy ways of doing things. A slightly more involved way is, but much more potentially much more flexible, is using Amazon Web Services. So Amazon has a bunch of servers which it makes available for people to use at a cost. So So you would need to go to Amazon Web Services and get an account. There, if you're joining for the first time, you get a year free on one of the smallest instances. So an instance is kind of like what Amazon calls a single computer on the cloud. So for a small instance, you can use it for free for a year. Otherwise, they are very cheap. The ones that I use are typically something like 10 cents, 10 South African cents per hour to use. They do get more expensive if you're using like particularly specialized, like if you want to use GPUs and stuff like that, then you're probably talking about like 10 or 20 Rand per hour. And that can quickly add up. But unless you're doing quite specialized work, you probably don't need those. So I'd start the section with a huge caveat. So like, just be very careful about what you do on Amazon Web Services, because while these instances are open or being used, you're getting billed for them. And so don't forget to close them down. Don't forget to check exactly what instance type you're using. I'll tell you in a second, like which are the ones that I suggest using to start off with, and just basically to be careful. It also needs a credit card. There's some educational options that you can set up if you're a teacher. You can set up a classroom for your students and give them some free credits. If you're a researcher, you can apply for free credits, and I've found they're quite generous. Like you get something like $100 or $200 worth of credits quite easily if you're a researcher at an academic institution. Okay, so AWS is Amazon Web Services, and there are a bunch of web services. The one that we want to use is the cloud computing, and that's called EC2, Elastic Cloud 2. So you just have to find your way there, and you land up at this kind of dashboard. Now, I'm going to show the way that I'm going to show you is the way that I do it, which is the cheapest way, and that's through the spot requests. So you can either request instances through the instances tab. Those are more expensive, but they're kind of guaranteed to work. There's a spot market for these instances, which basically says they'll be cheaper, but if there's a lot of demand for these kind of like more expensive ones, you may not get served. In practice, I've never not been served using these spot requests, and so that's the way that I just always do it. So click spot requests. These are just things that I've tested in the past or recently, and say request spot instances. So the two important bits of information that you need are like what type of computer are you looking for? So what type of instance do you want? So that will be like what operating system does it have? What software comes pre-installed? And that's about it. So like for example, you can get a Linux machine, or you can get an Ubuntu machine, or you can get something that has RStudio pre-installed, or you can have something that has Python pre-installed. And so there are a whole bunch of these AMIs or Amazon machine images. Like someone's done it and made these available. So the one that I recommend using, that has RStudio and everything set up, has been put up by this guy Louis Asfit. And so at the end of this talk, I give all of these links, but basically there are all of these computers, all of these links will take you directly through to that screen that I've just shown you, and will load one of these instances. So the one that I recommend using is just grab this first one, and then where it says AMI, we're going to say search for AMI, and then in the community AMIs, just paste that ID. Yeah, I want to close that, did I? So this will come up. It says RStudio, and it says everything that's pre-installed. So it's an Ubuntu machine, and it's got some of the deep learning libraries that you can use in RStudio pre-installed. So I select that one. So that's the first important thing. That says I'm going to set up an RStudio instance. or an instance with RStudio pre-installed. The second thing is the instance type, and that's basically the amount of computational resources that you want. So there are these loads of different types of instances, and they all have different strengths and weaknesses. The ones that are just kind of like your standard instances for like general statistical that will be fine for general statistical analyses are probably these T2 and T3 instances, and you get an idea of the prices over here. So like I've had this for more than a year, so I pay for even the smallest instance, which is this T2 micro. This is the one that's free for the first year, but it's almost free. You know, it's a fraction of a US cent. So anyway, I'll select one of those. The expensive ones to avoid start with a P. So just remember, P is bad. And you can maybe look, yeah, so those can be like $4 an hour, but you wouldn't need this. Yeah, just be careful. Yeah, so a fast computer is not a substitute for bad code, I think. Yeah, unless it's a really big one. Okay, so select the instance, and then if you use this a bit more often, the way that I'll show it is not super secure. So if you've got very sensitive data, then you probably want to start getting into these key pairs, which provide a greater, like when you log into the instance, there's some authentication where you kind of you show your identity and it's recognized by Amazon Web Services. So if you are using it for sensitive analyses, you probably want to read up more on that. But the easiest thing is just to leave it out. There is still a password, so not anyone can access this instance. So I feel like it's fine for most people's purposes. Then you say, how much capacity do you need? And this is something that I find really useful, that you can start more than one instance at a time. So this is particularly useful for if you're doing simulation studies. Say you want to like have 1,000 simulation runs, and each of those takes quite a long time. What you can do is what I'll do here is just create 5 instances. They're all going to be the same, and I just split my simulation runs 200 per instance. So it's kind of like a very crude version of parallelization. Like you're basically just creating five computers and you're distributing your work across them. It only really works for stuff like simulations where everything is independent, all runs are independent of each other. So it's not going to work for like an MCMC or something like that. Anyway, I found that that's quite useful. And those are the 3 things that you need to set. Everything else can stay as is. You can see I'm paying 2 cents per hour, and that's estimated 70% savings compared to what I would be paying if I did it through that instances tab. So it's useful to do things through spot instances, I think. Then there's just this warning that says you're not doing things very securely, so I won't be able to connect to it unless I've got a password. I've got a password, so it will create those instances. So this will take a little while to load, but I'll go back to this instances tab, which contains all of the information about these instances that I've just started. And so each of these is going to be a single instance that I can access with a URL through a browser. Right. So there's one thing that I forgot to do when I set up these instances, and that's tell the instance that I'm going to be accessing it through a web browser and allow it to, like when I access it through a web browser, I need to change the security group to say allow this instance to be accessed through a browser. So I'm going to just change that by saying I click on these view inbound rules. Oh, actually that's fine. So it must be accessible through port 80, and that just says I can access it through a browser. So if that's not there, then you can add that as a rule, and there's some instructions on there's an accompanying document that will we'll share with this with these materials. But basically, we can just edit these inbound rules. Sure. Yeah. By clicking edit and then adding a rule that says access or allow access through port 80. I've already got this, so I don't need to edit it. Okay. So almost there. So each of these instances has an IP address, and I can copy that and paste it into a browser. So I'm not sure whether these will be fully up and running yet, but let's see. Yeah. So then I get this get a sign-in window for all of this information about usernames and like what username to use and what password to use is on Louis Aslet's website. But the username is always RStudio, and then the password is the instance ID. So that's the password I need to get into the instance. So I would need to do this for each of these 5 instances that I've started, that I've set running, each in a separate browser tab. So once I've done this, this is now similar to what RStudio Cloud did. I'm going to load something that looks exactly like RStudio, and then I'll be working on the Amazon Web Services cloud computing resources. Okay, so I might do, I can do a little bit of coding, and then I might want to save this. So now, if I close down this instance, I'm going to lose everything that I've done. So the last kind of piece of the puzzle is to save the work that you've done. There are a couple of different ways to do this, but this is where the downside of these spot instances are, and that's that if you close them, everything is gone. So you have to save your work. If you use the instances, there's a difference between stopping an instance and terminating an instance, and stopping it kind of pauses it. With spot these things that we're using, you can kind of only terminate. So what we need to do is to say, okay, I'm working on this. I've done some work, and I want to save my work so that it's there for me when I come back next time. So you'd highlight the instance you're working on, and under Actions, say Image and create an image. So I'll just call this a temporary demonstration and create an image. That takes a snapshot of the instance in its current state. So it'll have all of all of your script files, all of your data, and stuff like that. Any packages that you've installed, stuff like that. So when you come back and want to work later on, you've got everything that you were working with. There's a question.
Could you perhaps link the RStudio to an S3 bucket where all of the data is sitting in the S3 bucket and all of the outputs just fall into the S3 bucket?
Yeah.
Just so that you have someone to access all of that.
Yeah.
You don't want to terminate or shut down the instance, the RStudio instance.
Yeah, you can do that. Yeah. So what I've showed you is kind of starting this instance from scratch. If you've saved this image now, if you wanted to start it again, like, you come back a few days later, rather than starting from spot requests, no, actually that's not true. Let's try do this one more time. When you request, if you request a spot instance, before we put in these like the clean, fresh Louis Astlett images. When I search for an AMI, I just need to select the thing that I was working with. So it appears under these, under my AMIs. So these are a bunch of the AMIs that I work with, and they just have slightly different things installed on them. So now the most important bit, what to do once you're totally finished. So under instances, you'll see I've got these instances running. I want to stop them so that I don't keep paying. So I highlight all of them, say actions, instance state, and terminate. And say terminate. So it'll say shutting down, and then when they've stopped, that will turn red and it will say terminated. And at that stage, you kind of save. So don't forget to terminate your instances. You can also do it through the spot requests by saying, ticking here and saying cancel spot request. That will also terminate the instances, so same thing. So that will terminate all of the instances that you started up with a spot request. Okay, so
so you very rarely go to the whole clean, fresh, Louis Astlett approach. You usually just set up a couple the way you would like Louis Astlett plus what you would usually use, and you just open those each time.
Yeah, exactly. Yeah.
But you pay, I assume, that you're paying for the storage of the image. So you store that image, and then you might want to create a new spot instance.
Yeah.
If you store that image for a month, there's a cost associated.
That's an important point that I didn't mention. So you pay for everything. So yeah, you pay for these images, the ones that you store, but they are a fraction of the cost of actually running an instance. So I think usually with these, like I have whatever it was, like I probably should clean them up, but I usually have like something like 5 of them, and then I probably pay something like 50 Rand a month to have those, like just for, in a month where I don't use them at all, just for the storage, you probably pay something like 50, maybe to 100 Rand a month. So yeah, it's not nothing, and you kind of have to balance off the cost of installing. Like if you're just installing a few packages, you probably can do that. Like don't keep an image just for that. But if you're installing some libraries that are difficult to install or that are like time consuming, or you also pay for you pay for the amount of data that you store. But I think the smallest storage is something a few gigabytes. So unless you've got really storing a lot of data, you're not going to hit that upper limit quickly. Okay, so just to summarize, I kind of looked at these in reverse order, but they're just three different options for making your workflow a little bit more efficient. So the first is RStudio Jobs, which I kind of only have come across recently, but seems really useful just as an everyday tool. That just works locally on your machine. So yeah, easy if you just want to free up a window in RStudio to actually keep on working. But it's on your own machine, and it's not remote with all of the downsides that we're trying to get away from with cloud computing. RStudio, I also haven't used this very much, so I can't say too much about it. But it looks very useful for a lot of kinds of work, like especially I guess for students that might not have credit cards and the kind of things that you might need for Amazon. It looks like a nice option. It does mean that it's tied to RStudio. So if you're doing analyses in other languages or using other pieces of software, I don't know how easy it is to do that. And then the most flexible but most costly option is Amazon Web Services. There are other options. So there's Google Cloud, and no doubt there's a whole bunch of other ones. But these are just the three that I know about, and that have easy interfaces that you can use without having to like get into the command line tools. So all of these, all of the stuff that I've talked about is basically in these links. So I've got a more detailed set of instructions for the Amazon Web Services stuff at this link. There are two neat videos on using RStudio Cloud, and well, actually no, just one video on RStudio Cloud, and this blog post on RStudio Jobs tells you a little bit more about like what you can get out of RStudio Jobs in terms of like stuff like pulling a repo from GitHub and stuff like that. Okay, so that's all that I have, but happy to take some questions. Yeah, Matt?
A couple of questions. So